All right, I am going to talk to you about activity 4.3, motion in one direction. And there's going to be math, and it's going to be easy math. So here we go. The first thing we're going to do, though, is that we're going to read the problem. You should all watch this describing motion tutorial video. Just assume that everything that is in here for Project Lead the Way is deemed to be valuable for you. So the problem says, after school, a student jogged from school to the library. It took 35 minutes to get to the library, where he spent 10 minutes browsing and checking out a book. He then walked to the coffee shop on the same street in 15 minutes. He spent 40 minutes at the table, shop, and reading the book before he went home. He walked home in 25 minutes and remained there until the next morning. So you just start with the first problem. It took him 35 minutes to get to the library, and it's 8/10 of a mile. So first of all, he's starting off at 0 at 8/10 of a mile. So we'll put that on 0. You're not going to be doing this in Excel. I'm just using this to show you. And at 35 minutes, he made it to 8/10 of a mile. So there's 35 minutes, and there is 8/10 of a mile. So we've got our 35 minutes on the clock. We don't have to worry about that time frame anymore. And he spent 10 minutes browsing. So I'm going to do Control D, and that gives me another line. And I'm going to put this end right here. And then I'm going to drag this, and he spent 10 minutes. So that should be 35 to 45, right? Okay, at that point, he walked to the coffee shop on the same street in 15 minutes. So that is 9/10 of a mile. But we're talking about total displacement from home every time. That means we add this value to this value. So we get 1.7 miles is his new distance. So when I do Control D, I get another line, and we're going to go up to 1.7 miles. So I'm going to put this here, and this is going to go up to 1.7 miles in 10 minutes. So up to 1.7 miles, which would be right there. And our 10 minutes is between here and here, which is 50 to 45. He then spent 40 minutes sitting at a table. So 40 plus 55 is 95, right? That's funny. I expect you actually to answer me. So 95. And there is 95. Now, I'm going to let you finish it. That should be enough for you to understand what it is. You've got to read it and apply it to this. Now, we're going to then, oops, didn't want to do that. Use the distances in the diagram above to draw your motion graph. There it is right there. Using your motion graph, what is the student's displacement after an hour and a half? Well, on our graph right here, we would find an hour and a half, which is 90 minutes, and his total displacement was 1.7 miles. See how easy that is? We can look anywhere along the line. His total displacement is 1.7 miles. And then what's the total distance he had walked after an hour and a half? Y'all can figure that out. You are smart. So the following graph represents the motion of a ball thrown straight up into the air. Using the graph, what is the displacement of the ball at t equals 4 seconds? Well, here's 4 seconds. Displacement in feet is 20. It's 40 feet. See that? That's easy, isn't it? Okay, I am going to go back up here. Let's see. Okay, those are all questions you can answer. So what is the average speed of the ball between t and 0 and t and 2 seconds? You would have 3 values here. You would have 0, 60, and 80, and you'd find the average of those values to answer that. And notice again that you get a little balloon. There you go. Tells you what it is. So we want to create a motion graph on orthographic grid paper, but do not define units or scales. Exchange your motion graph with a classmate. Write a story about a description of a scenario that might be represented by your partner's graph. Label the axes, show scales and units for the graph. So this is an interesting thing. You draw something like this without scales on it. So without the 0, 1, 2, 3 and the 20, 30, 40 minutes here. And then you're going to exchange your motion graph with your classmate. And your classmate is going to write the story or a description of the scenario that you did. And then he's going to label the axes and show the scale. You're going to do this in your journals. So you're going to have to share this with another person. You then have to answer these questions in your journal. And that's probably enough for this video.